Okay, this is the integration questions which asked by my student in my Facebook page. They just personally messaged me to ask about this question. However, I do not have the answer of this question, so I just do whatever I can. Hope my answer is correct. Right. This one actually, they didn't give me the question, but I think what they want is they want to find the shaded region. So, what is the shaded region? Okay, I think this is in Add Maths for integration topic. So, because integration topic actually will teach you how to find the shaded region in the curve. Alright, something like this. Okay, so before you start to do this one, you must able to see if you want to find the shaded region, you cannot straight away integrate the curve. Well, a lot of students might think that I just integrate the curve, then I can get the shaded region. Then you will make a small mistake, because if you integrate the curve from, let's say, from 1 to 2, okay, I try to draw a dashed line over here. Okay, let's say this is 1, this is 2. If I integrate the curve from 1 to 2, the area I will got this area. Okay, this is the area I will got if I integrate from 1 to 2. Okay, I will got this area. Okay, it's not the orange color one, because what? Because I integrate the curve toward x-axis. What? Mean from the curve to x-axis is the green color area. Is this area I will got. Of course, it's not included the bottom one because I actually draw out of the x-axis a little bit. Okay, so this is the area I will got if I integrate the curve to from 1 to 2. So what I need to do is, you got two methods. One is to find the area of trapezium, and then minus the green color area, you can find the shaded region, or you can straight away integrate the straight line from 1 to 2. Then you integrate the straight line, you will got toward x-axis, right? You will got every part of here, and then you minus the green color part. You can get the orange color part, right? So we have the equation of the straight line already. So what I will do is I will integrate the straight line from 1 to 2. I will integrate the curve from 1 to 2. Okay, what is the equation of the straight line? Okay, when you toward x-axis, so we will integrate, I call this one y1, this one is y2. So I integrate y1 minus I integrate y2. Because if I integrate y1, means I integrate this straight line, I will got the trapezium. Do you see the trapezium? And then I integrate 1 to 2, y2, then I will got the green color part. Then I can get the orange color part. Simple, right? Okay, but then you have a little bit issue over here, because this is not yet y as a subject, so we need to change this one to y equals to minus 2x plus 7. Okay, then I just put it back. Okay, so 1, 2, this is negative 2x plus 7, and then I integrate this one. 1, 2, what is the y for the curve will be x plus 4. This is x, I think this is square. Okay, so I write the x square become x negative 2. It's the same thing, right? Because over x square, I can write it this way. Okay, then I start to integrate. Okay, so this one is simple. So this one will be negative 2x square over 2 plus 7x. Okay, this is 2, 1 minus, I integrate this one. This one I got x square over 2. Okay, this is like negative 2 plus 1. I will got plus 4x negative 1 over negative 1. Okay, same is from 1 to 2. Alright. Integration should have no issue, just the power plus 1 divided by total power. Okay, this is x power of 1, I plus 1 become 2 divided by total power is 2. Alright, simple, right? Okay, then I just substitute the 2 into it, minus I substitute the 1 into all the x. So I do this part first. So I will got, okay, simplify this one, called negative x square. So negative x square, negative 2 square plus 7, 2, okay, and then I minus, substitute 1 into it is negative 1 square plus 7, 1. Okay, and then I minus this one. I substitute the 2 into it, is what? Is the 2 square over 2 plus, okay, this one 4x power of negative 1, actually I can put at the bottom, and then negative 1 over here, this is plus, right? I write in minus 4 over x. X will be 2. Okay, and then I minus, put the 1 into it, is 1 square over 2 minus 4 over 1. Okay, this one shouldn't be problem, right? So I just write this one again. Okay, because some students might feel confused in this part. This actually is just minus 4 over x. Okay, because x is power negative 1. Alright, so then, yeah, if you can use calculator, you just use calculator. This one should be simple. Negative 4 plus 14. So here I will got 10. Okay, minus this one is like negative 1 plus 7 is minus 6. Okay, and then we minus, okay, this one we minus this one. This one is actually 4 over 2 is 2. 2 minus 2, this is 0. Okay, 4 over 2. Alright, this is 0. Okay, and then this one will be the negative. Okay, let me see. Oh, this is 0 minus this one. This is 1 over 2 minus 4. So 1 over 2 minus 4, we will got negative 7 over 2. So basically this is minus negative is 7 over 2. So this one will be 4 plus, is 4 minus 7 over 2. So it's 1 over 2. Yeah. This is the shaded region, or you can write unit square if you want. Okay, it's not really difficult. Of course, you can think that, how about if I find the trapezium? Yeah, you can do so if you want. If you find the trapezium, what is the length over here is 1. The length over here from the coordinate we know is 5. This is 3. So I can use 1 over 2, a plus b, right? 3 plus 5, multiple with the height is 1. So this one, what you will got? You will got 1 over 2 multiple 8 multiple 1. So you got 4 unit square. So 4 unit square, you can find out, actually if I integrate this one, I get 4 also. Do you see? I got 4 also. So basically you can do it like find the trapezium area, or you straight away integrate the straight line from 1 to 2, you will get the same answer. Alright, so that means this area is actually just half unit square. Alright, okay, after I finish this part, the only difficult part of this question is a lot of students do not know actually when you integrate this curve you got the bottom part. It's not this part, it's the bottom part. Okay, if you can understand this one, you can easily do this one. You remember whenever you integrate no matter straight line or curve toward x-axis is all the area from the curve to x-axis. Okay, if you integrate the curve toward y-axis is from the curve toward y-axis. Okay, it's not included the middle one. Okay, must remember this. Okay, then we go to the other question. Okay, this question. For me, I think this question is not coming out in the SPM level because it's just a little bit too much. But since the student asked me, so I just explained about this one. Okay, he gives you a diagram and then it says, calculates the volume generated when the shaded region is revolved 360 about the y-axis. Means actually this shaded region, he will turn 360 on the y-axis. Okay, so obviously we know this is 0. Okay, so the first step is we have to find the intersection point A. So how to find the intersection point? We do the simultaneous equation. Okay, so let's call this one 1, this one is 2. So what I do is I substitute 1 into 2. Oh, I substitute 2 into 1, sorry. 2 into 1, I substitute this one into that. So I got 8y equals to 3, y squared minus 1. So 8y will equals to 3y squared minus 3. So I move everything 0. So 3y squared minus 8y minus 3. Yeah. So I just factorize. What I will got is, okay, this is 3y, this is y, and then I will got, okay, this is 3, this is 1. And then this is negative, this is positive. Alright, so blah, 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 blah. Am I correct? Let's see, 3y negative 3 negative 1. Yeah, correct. So what I will got over here is, yeah, y will equals to negative 1 over 3, or y will equals to, yeah, or y will equals to, or y will equals to 3. Obviously, for point A is positive value, so y will equals to 3. Alright, so in order to make you understand better, actually I draw a diagram, it's exactly the same. Okay, but just now we find out y equals to 3, so what I do is, I draw a dashed line over here. Okay, this is 1. Okay, this is 1, so this one is 3. Okay, if I rotate the shaded region into the y-axis, I will form something like a cone over here. Okay, I will got something like this. Okay, let me just randomly draw something for you to understand. Okay, I will got something like this. Okay, if I rotate 360 degree. Okay, but then in order to calculate it, I believe that we have to, okay, because you integrate the curve, right? You integrate the curve toward y-axis. You integrate the curve toward y-axis. This is the curve, right? Toward y-axis, actually you got this area, the green color area I draw. Rotate 360 only. You wouldn't get the shaded region, but then the question asks you, how about the shaded region rotate 360 degree on the y-axis? So what I want you to do is, I want you to integrate this triangle, rotate 360 degree on the y-axis. Means I rotate this one 360 degree on the y-axis, and then I integrate the curve. This is a small part, 1 and 3. Okay, this part rotate. So I use the big one. Do you see this? The big one minus the small one. Then I can get the shaded region. So I hope you got the idea. So basically I will use the big one. Okay, I minus the small one. Okay, this is a small one, this is a big one. Alright. Okay, of course the diagram is look like this, just give you some idea. So first is, what I do is, okay, I got this one is 3, this from 0, I will integrate the straight line from 0s to 3, and then rotate 360 degree on the y-axis. Okay. Now this part will be slightly difficult. Okay, when you want to rotate on the y-axis, remember you have to make x as a subject. So I have to change this one to x will equals to 8y over 3. Okay, this one already x as a subject. Okay, then I start to integrate. Okay, so the formula actually is like pi x squared for volume. So I will use the pi x squared for the straight line. So I call this one x1, x2. Okay, pi x1 squared minus pi x2 squared. Okay, why minus? Because this is what I say. If I integrate the straight line from 0 to 3, I will got this part rotate 360 degrees. So I will got the bigger something like corner, and then I minus the small one is actually from 1 to 3. From 1 to 3 for the curve, because the curve toward y-axis is only the green color part. Okay, so I just minus, I can get the shaded region. The shaded region actually is only this part, rotate 360 degree lah. So actually I use the orange color to draw out what will happen if you rotate 360 degree. Okay, so integration law tells us that actually we can take the pi out. Okay, 0 to 3. What is my x? My x will be 8y over 3 square. Minus this one, pi I take outside. My x for this one is y square minus 1 square. Okay, before I start to integrate, I just expand them. Okay, I just expand them. For this one, it's just 64y square over 9. Okay, minus pi, expand this one also. This one will become y power of 4 minus 2y square plus 1. Okay, then now only I start to do the integration. Integration plus 1 divided by total power, right? So this one is called 64y cubed over divided by 3 is 27 on the bottom. So this is 30 minus pi. Okay, integrate this one, it become y power of 5 divided by 5 minus 2y power of 3 divided by 3 plus y. Okay, 3, 1. Okay, then what you need to do is, put the value in. 0 put into it, whole thing will become 0, so nothing special. So I put the 3 into it, so I get 3 cubed. 3 cubed is 27, 27 over 27, so this the first one is 64 pi. You can press calculator if you couldn't, because 3 cubed is 27. 27 and 27 I simplified, become 1, so 64 multiple pi minus 0, so it's 64 pi. Alright, for this one it'll be slightly complicated. Okay, let me do something. Okay, pi, I put a bracket lah. Okay, I put the 3 into it first. 3 power of 5, 3 power of 5 I believe is like, let me press calculator, it will be easy. 3 power of 5, oops, is 243. Okay, 243 over 5 minus 3 power of 3 is 27 with 54 over 3 plus 3. Okay, the whole thing minus, okay, right at the bottom, not enough space. So this one will be 1 over 5 minus 2 over 3 plus 1. Close bracket. Alright. Okay, then just let me continue the calculation. Yeah, calculation will be slightly complicated if you are not so good in the integration. So I will continue here. Here is 64 pi minus pi I leave outside. Okay, let me solve this number. So I recommend you to use calculator just to not confuse yourself. So just press 243 over 5 minus 54 over 3 plus 3. Okay, I got 168 over 5 minus this one. So I will got 1 over 5 minus 2 over 3 plus 1. Okay, this one is 8 over 15. Okay, then I just solve it, 64 pi. I just solve the inside value. So just 168 over 5 minus answer. So this one I will got minus 496 over 15 pi. So I just use 64 minus the answer. Okay, I will got 464 over 15 pi. Okay, if you want to write, you can write something like unit cube lah, because this is volume. Okay, yeah. So this is what will happen if he asks you to find the volume. So basically, when I find the 64 pi, actually is this bigger volume. And then this part actually is the green color one, rotate 360 degree on the y-axis. It's the green color part. Okay, so basically for the question like this, you must able to imagine only this shape region rotate 360 degree over here. What will it become? Okay, so yeah, because if you integrate the curve toward y-axis, you will not get the orange color part. You will got this area. Correct or not? Because this is the curve toward y-axis. Unless you integrate this side. Okay, this side is the curve toward y-axis. You will got this part. But now is the shaded region rotate 360 degree. So you must be able to differentiate it lah. Okay, and then I'm not sure whether this answer is correct or not, because yeah, I do not have any answer. So if the student know the answer, or you got the exactly same question, yeah, you can just tell me whether my answer is right or wrong. Yeah, but then I think the step and the method itself is correct, and then I hope you can understand about this kind of question, because normally in the SPM, your volume one is very simple. He just asks you to find. Most of the time you do not need to like do something like this. Have to use the bigger volume minus the smaller volume in order to get this part. Yeah, most of the time you can straight away find. But before I end this video, just let me remind you something. Okay, yeah, because for volume, a lot of students sometimes they're very confused. Okay, let's say you got something like this. Okay, this is y, this is x, of course. Or you got something like this. Okay, this is y, this is x. Obviously, this one, in this part, rotate 360 degree on the x-axis. Okay, so I just write 360 degree on x-axis. Just write the short form now, x-axis. Okay, this one is rotate 360 degree on the y-axis. That's it. Okay, just imagine something like this lah. So he will rotate. Okay, like this. This one will rotate like this. Okay, so what is the formula if you rotate on the x-axis? Okay, rotate on the x-axis the formula is something like this. Okay, depend this one. Okay, let's say we put 0 to 5 for both lah. 0 to 5 for both will be easy. So we integrate 0 to 5, and then on the x-axis, right? So what you need to do is pi y square and then dx. Okay, then only you see what is your y. Let's say in this one, let's say y equals to like x plus 1 square root, then you put x plus 1 square root and then square it. Okay, for this one it's the same, 0 to 5, but then you rotate on the y-axis, right? When you rotate to the y-axis, here is definitely dy already one. So when here is dy, so what you need to write, this is x squared, and then must always have pi. So this is pi x squared. So remember, if you rotate on the x-axis, will be dx. So when here is dx, here will be y. Just opposite lah. So you rotate on the y-axis, here will be dy, because it's toward y-axis. So here will be opposite, so it's x squared. Must have the square, because a lot of students will forget the square or forget the pi. So it's pi x squared. This is pi y squared. Okay, just depend how actually the object will actually rotate. All right. So please, just okay. Maybe I just talk too much, but I must say something like this. Okay, if the question asks you to find this area, this is different with this one, because this one toward x-axis is very simple. The curve toward x-axis is this area, but then for this one, the curve toward x-axis is this area only, because this is the curve one. Toward x-axis is this area. You will not get the black color one. Okay, so black color one, maybe you have to integrate the straight line toward x-axis minus the curve toward x-axis, then you can get the black color region. So must always understand how actually the curve toward x-axis mean. Okay, I hope this video can give you understand better about volume and area. Yeah, if you find any mistake, just let me know in the comment, or you can personal message me in my Facebook. Right, thanks for watching. Hope you learned a lot in this video. Thanks. Bye.